Did you know that over 2,000 years ago, a Greek librarian used geometry to determine the circumference of the Earth?
How did Aristophanes find the circumference of the Earth? What are the angle relationships between parallel lines and a transversal?
The concept of the Earth being a large sphere was not unknown to the ancient Greeks. And everyday observations, such as the disappearance of ships below the horizon, indicated that the Earth might be spherical or round. But how large was it? The person who figured it out was a librarian named Aristophanes, who lived in Alexandria, Egypt about 300 BC. While looking through a scroll one day, he read that at noon on the longest day of the year, a vertical column cast no shadow in Syene, a city south of Alexandria. Aristophanes knew that this did not happen in Alexandria. He thought to himself, how was it possible to have shadows in Alexandria and not in Syene at the same time of day? Aristophanes figured out that the sun must be directly overhead in Syene, but not in Alexandria. Aha! Here was proof that the Earth's surface is curved. Using a little geometry, Aristophanes set out to determine the circumference of the Earth and find out just how big it is.
Just like our pizza example, if our friend Aristophanes could determine the central angle at the center of the Earth and the length of the edge or arc, then he could figure out the circumference of the Earth. Now, finding the length of the edge or arc was fairly simple math. Aristophanes asked a friend to walk from Alexandria to Syene to measure the distance between the two cities. His friend estimated the distance to be around 800 kilometers, or about 500 miles. Finding the central angle, however, would take some geometry. First, Aristophanes assumed, correctly I might add, that the sun's rays are parallel, since the sun is so far away. Check this out. In this diagram, we can see that there is no shadow at Syene, while there is a shadow in Alexandria. The line that is formed by the gnomon, or vertical column at Alexandria, and the center of the Earth, cuts or intersects the two parallel lines formed from the sun's rays. A line that intersects two parallel lines is called a transversal. The two angles formed from the transversal line and the parallel lines are called alternate interior angles. And, according to geometric rule, they are equal. Let's prove it. Take a piece of paper of any width and draw a diagonal line on it. Label the angles A and B just like this. Now, cut the paper along the diagonal so you have two triangles. Compare angles A and B by placing one angle on top of the other. Hey, what do you notice?
The angles are equal no matter what size paper you started with.
Right. When two parallel lines are intersected by a transversal, the alternate interior angles are equal. Aristophanes was quite a geometer. From his measurements, Aristophanes calculated the sun's rays made an angle of 7.5 degrees at Alexandria. Now, since this angle was formed by two parallel lines and a transversal, the central angle of the Earth must also be 7.5 degrees. By knowing these two things, the central angle and the distance from Alexandria to Syene, Aristophanes calculated the circumference of the Earth. 360 degrees divided by 7.5 degrees equals 48 slices of the Earth. Are you still with me? Okay, hang tight, we're almost there. Now, if you remembered that the estimated distance between Alexandria and Syene is 800 kilometers, and you multiply that distance by the number of slices in the Earth, 48, what is the circumference of the Earth? Well, if you estimated that distance to be 38,000 kilometers, you're absolutely right. Aristophanes' estimate was really close to the Earth's circumference, which is 40,074 kilometers. His percentage error was about 5% and was probably due to an error in the distance between the two cities. 5%? That's pretty good, considering Aristophanes used only his feet, his eyes, his imagination, and of course, his knowledge of geometry.